Good afternoon to all. Today we are going to learn about that coordination compounds, the rules of coordination compound. That is, today our learning objective is to learn about the nomenclature of coordination compound. Nomenclature of coordination compound. Okay. Anyhow, we have, I think that the four or five rules in our coordination compound. If you are learning the five rules, we can easily write the name for the coordination complex. Anyhow, the basically we are learning about the four important points. One is about the cations. Second one we are going to learn about the ligand. The third one we are going to learn about the central metal ion. Next we are going to learn about the ion of the complex, charge of the complex. If you are knowing the 4 points, first one is a simple cation. Which one is the simple cation? And about the ligand. Previous video I told you that ligand is attached to the central metal ion. Next about we are giving the name, focusing the name about the central metal ion. Next one is about the charge of the ion. If you know the 4 points, we can be easily say the name of the complex. So please all of you watch carefully today's video. Please write which are the rules for having the coordination complex. All of you take your note and listen carefully. The first one rule. What is about the first one rule? If you are naming the complex, first you should be start with cation. Simple cation. Here, for example, K4, FeCN6. This is one of a complex. Here, previous video I told you about that. The potassium K is a counter ion. Am I right? Okay, first we start with here. This is the cation. This is the simple cation. This is the complex anion. Am I right? That means this equation gives simple cation, that is 4K plus FeCN6 4 minus. Previously I told you about that. How will you gain this plus and how will you gain this minus? 4 minus. Okay, 4 plus. 4 plus. And also can write? Okay, no problem. Potassium plus. This is one of the coordination unit. Okay. First we start with potassium. Okay. This is what? Simple cation. Why it is simple cation? Can you say why is it simple cation? Because the potassium is occupied as single. It is a complex anion. Okay. So this is one of the complex. Here you should be named the cation first. Okay, the cation is named first, followed by the anion. Okay, first you name the cation first, followed by the anion complex. Okay, this is the first rule. What is about the first rule? The cation is named first, followed by the anion. Whether the ion is simple or complex. For example, what is the example? K4 FeCN6. Here you start with simple. This is a simple cation. So the name is first goes to potassium. I will tell how can we say this name. Okay. First start with here. Simple cation. Next goes to this coordination entity. Next start with ligand. This is the ligand. Ligand is attached to the central metal ion. This is the central metal ion. Am I right? Fe is the central metal. The Cn is the ligand. This is the simple cation. Okay. So start with first one for this complex because we have two metals. Am I right? potassium is also one of the metal and iron is also one of the metal. Am I right? So outside the cation, that is called the simple cation. First start with the name is started with simple cation. Next followed by the coordination entity. Second goes to ligand and third goes to the center metal ion. Okay? Simply I am saying the name of the complex. How can you say the name of the complex means? Potassium. Cn means ligand. Cn is the ligand. So ligand here means Cn. How much Cn is there? 6 Cn. So we have 1 means mono, 2 means di, 3 means tri, 4 means tetra, 5 means penta, and 6 means hexa. Hexacyno. Okay, hexacyno. Here, this is the charge of this potassium. I told you here. This is the plus charge, and this coordination entity is the minus charge. So minus charge ends with the 8. Okay. So Fe means ion. Am I right? Ferrous or ferric we are saying. So potassium hexacyanoferrate. This oxidation state is 2. Previous video I told you about that how to find out the oxidation state also. So ferrate 2. That is the name. I will tell you. So anyhow, this is one of the complex. First we usually start with the cation is named first, followed by the coordination entity. Okay, followed by the coordination, that is the entity. The symbol ion may be complex. Okay, that is the first one, first rule. The second one example. This is for K4FeCN. The second one example is, what is about the second one example? For the another one complex, that is CONH36, CONH3, 6. Another one complex, Cl3. Okay, here, this can be written as, first one is the complex cation, CO NH3 6 times 3 plus 3 Cl minus. This is the complex cation. This is the simple anion. Can you understand? The previous one, K4FeCN6. K4FeCN6. Here I told you 4K plus FeCN6 4 minus. Here this is what? Simple cation. Complex anion. Can you differentiate the both two equations? First one is, we are splitting here. This is the coordination compound. Counter ion only leaving out. Am I right? First one is a simple cation, complex anion. Okay, complex anion. Second one, complex cation, simple anion. Can you differentiate? This is the first equation. That is a potassium hexacyanoferrate 2. I will explain how can we say. First I am saying the rules. The first one is simple cation, complex anion. Here divided here. Okay. Simple cation, that is a simple cation plus complex anion. This is the first one. So we are starting with potassium. The first name priority goes to potassium. In second case, this is the complex cation, next one simple anion. Here, you should be named the, here first. There is a coordination entity first. This is the second. Here, this is the first, coordination entity is the second. Okay. Here, first one, potassium is first, next the coordination entity is the second. In this equation, this is first and this is the second. Clear? And anyhow, start with the Ligon first, next central metal ion, next go to chloride ions. Okay. The third category, complex cation and the complex anion. Here, the complex cation and the complex anion. You can be write on the example. PTNH3 4 times. This is one of the complex. Again, PTCl4. This is another one. Okay. This is also 2 plus. This is also 2 minus. This is the third one. Here, NH3 4 times. This, don't write here, okay? This is because the complex. Don't write the charge here. Here write 2 plus. And next one, PTCl4 2 minus. This is the complex cation. This is the complex anion. Okay, anyhow, can you differentiate the two? First one point, I told you that what is the first point is the cation is named first, followed by the coordination entity. Okay, first we should be named the cation. That is the first rule. For about the first equation, which one is the cation? The second equation, which one is the cation? The third equation, which one is the cation? That's the question. The first one is this is a simple cation. The second one is what? The second one is a simple anion. Clear? The third one is they are equally shared. There is a complex cation, complex anion. So first of all, you should learn the rule first. Anyhow, the first one we should be give the priority to simple cation. Next for complex anion. The second category, you give the priority to complex cation and next go to simple anion. The third one, first goes to the priority complex cation, next go to complex anion. This is the condition. Clear? Can you understand? What is about the first rule? Anyhow, you should be give the name to first one cation. Okay, cation. For the first equation, the second equation simple complex cation, the third equation complex cation. Next, the second rule. What is about the second rule? We can do this second rule. The simple ions. We have some simple ions, maybe sodium, potassium, like that. These are the simple ions. Chloride, nitrate, sulfates. They are simple ions. Okay. The simple ions are named as in other ionic compound. Simple ions are named as. What's the second rule? The simple ions are named as in other ionic compound. The simple ions are named as in other ionic compound. How can you give the simple ions? Maybe this one. Sodium. What is the symbol of sodium? We can write the name. Okay, sodium. Can you see? Sodium symbol Na. Sodium ions. That means symbol Na plus. These are what? Simple cation. Simple cation. We can take the potassium. How do you write potassium ion? K plus. Plus means cation. Copper. Cu 2 plus. Na 1 plus. 1Na plus or Na 1 plus. Potassium K plus or K 1 plus. Copper Cu 2 plus. These are all what? Simple cation. Can you say about the simple anion? Simple anion. What is about the simple anion? We can be write chloride. Write Cl minus, symbol anion. Nitrate, NO3 minus. Nitrate, you should be write the name, nitrate. Nitrate. NO3 minus, nitrate. Sulfate. SO4 2 minus, sulfate. Okay, anyhow, these are all what? It's a sodium Na plus, K plus, Cu2 plus. These are all plus means symbol cation. We are saying plus charge. We are saying symbol cation. The symbol anion means Cl minus, NO3 minus, SO4 2 minus. These are all what? Symbol anion. Okay, anyhow, about the second rule is over. What is about the second rule? The symbol ions are named as in the other ionic compound. Clear? What is about the second rule? The symbol ions are named as in other ionic compound. The symbol ions are named as in other ionic compound. Okay, these are the examples. Next about the third rule. How can you say about the third rule? The third rule means to name the complex ion. Whenever you need to say the name for the complex ion, first you should be say the ligand name first. Next only you goes to where? Central metal ion. Clear? What's the third rule? It's very important. Third rule, you say the name first, the complex ion. Then the ligand name. Next only the third one is the central metal ion. Okay. Suppose when we are saying the ligand, sometimes the ligand may be 2 or 3, more than one ligand having means you should be give the priority to the alphabetical order. Okay, let us we can be wait. Okay, what I am going to say. First I am starting when I am giving the 2 example. I am giving the 2 example. That is K4 FeCN6. This is one of the complex. I told you that here the first priority goes to where the symbol cation. Okay. The second priority, for the second priority, FeCN6 4 minus. This is one of the coordination entity. Here, you should be say the first one, the ligand name. Okay, ligand name. This is about the cyno. Nowadays it is changed as a cynido, CYAN. DO, cynido. That's we are saying CN minus. Okay. Here we are also using kappa. Okay, kappa means K we are using K, kappa. Okay. For this is for kappa. We are using a capital K like that, kappa. Okay. Here you should be say the name. Here how much cyno is there? 6. So 6 means we are using hexacyno. Next only goes to where? The Fe ion. Okay. The Fe metal. First one goes to the ligand. How much ligand is there? 6 ligand. Okay. 6 ligand is there. Am I right? 6 ligand. After the ligand over, next goes to where? Central metal ion. First priority goes to ligand. Second to about the central metal ion. Third you goes to the charge. Hexacyanoferrate, because having negative charge. Negative charge ends with 8. Negative charge ends with 8. 80. Negative charge ends with 8. Okay? Next goes to write this ion. Ferrate 2 ion. Okay, like that you write. Normal letter. Use the normal letter also. Okay. Hexacyanoferrate 2 ion. What's the name of this complex? Hexacyanoferrate this oxidation state also should be mentioned. That is ferrate 2 ions. Hexacyanoferrate 2 ion. How can how the name? First you say the Ligand name. How much Ligand is there? Here also one more having. That I told you that. Start with the cation, potassium. Okay. Potassium you write. That's the first priority. First one potassium. Next goes to Ligand hexacyano. Next goes to central metal ion. Okay. That is what? Fe. That is ion. Ferrate. Why the 8 come? 80, why the 8 is come? Because having the negative charge. Okay. Negative charge. So 8. The oxidation state for Fe is 2. So you mentioned 2 as the Roman letter. Having 1 ions. So you are having ions. Hexacyanoferrate 2 like that. Okay. That's the name. Next about another one more example I am giving. How can you say the name? Another one more example. We can use NH3. Okay, this is a neutral ligand. CO NH3 6 times 3 plus. Okay, this is another one complex. Ammonia is a neutral compound, so it can be used as amine. Ammonia NH3 can be written as amine. AMMINE, amine. How much ammonia is there here? Can you say how much ammonia is there? 6 ammonia, right? How much ammonia is there? 6 ammonia. So 1 means monoamine, 2 means diamine, 3 means triamine, 4 means tetraamine, 5 means pentamine, 6 means hexaamine. Okay, so the name is hexaamine. Cobalt oxidation state is plus 3. Okay, oxidation is Roman letter 3. Cobalt 3 ion. The previous example I told you that hexacyanoferrate 80, am I right? Because that complex having the negative charge ends with ATE. Here having the positive charge, so don't write here ATE, cobalt 8, no, it's a wrong answer. Write cobalt because the charge is plus. Cobalt 3 oxidation state, and previous video I told you about that to how to find out the oxidation state also. Those who have attended the video means it can be right, the oxidation state. Okay, anyhow, cobalt 3 ion. Here, I told you that suppose the ligand more than 1. Ligand is more than 1. How can you say the ligand is more than 1? For example, Cr, we are saying I am taking the chromium metal. Okay, chromium metal, it is a very favorite chromium metal. Chromium, ammonia, I am taking 3. And about the water molecules, H2O. Water molecules also I am taking 3. This is one of the complex. Okay, one of the complex. How can I say this name? Okay, this is central metal, okay, not the outside. Central metal, okay. One of the complex. Here, this is also ligand. This is also ligand. I told you that more than one ligand, which gives the priority, whether it is amine or this water molecules. Water molecules also neutral. Water should be say as aqua. What is it? Aqua, AQUA. Water can be written as aqua. Ammonia can be written as amine. As per the alphabetical order, which one is the first one? Alphabetical order. AA. Okay. First one, both are equal. Okay, because This also amine also start with A. Aqua also start with, this water also start with A, aqua. The second goes to, here M, here Q. So the first priority goes to amine, the second priority goes to water, aqua. So how much amine is there? 3 amine, am I right? So 1 means mono, 2 means di, 3 means tri, 4 means tetra, 5 means penta. Okay. So 3 means tri. How much ammonia is there? 3 ammonia. Triamine. Triamine. Clear? What's the name of this compound? Triamine. Triamine. How much water molecule is there? 3. So triaqua. AQA, aqua. Okay. Next, who is the central metaline? Chromium. Chromium. The oxygen state for chromium is 3. Chromium 3. That's the name of the complex. Can you say the name? Triamine. Why we are giving the first priority goes to amine? As per the alphabetical order we are giving. Triamine. Triaqua, chromium 3. The oxidation state for chromium is 3. Okay, chromium 3. Clear? That is about the third point. And also, I am explaining how can you naming the ligand. That is also very important. Okay, naming the ligand also very important. That means anionic ligand, cationic ligand, and also having neutral ligand. Anionic ligand. Okay. Second one, cationic. Third one is neutral ligand. Okay, anionic ligand. Which are the anionic ligand? Anionic ligand means having negative charge. Am I right? Having negative charge. Having negative charge. What is about the cationic ligand? Maybe positive charge. What is about the neutral ligand? No charge. We cannot give any charge. No charge. Okay, here anionic ligand, cationic ligand, and neutral ligand. This is the point about the third point. Okay, you should be learn the third point thoroughly. Here, anionic ligand. Anionic ligand means we can give the name Br minus, Br, Cl minus, F minus, OH minus. These are all what? These are all except on the anionic ligand. Br minus, you should be say the name bromido. Bromido. What is Br minus ion? Bromido. 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 Here. What is about the Cl minus ion? Chlorido. Chlorido. What about the F minus ion? Fluorido. Here, OH minus ion, hydroxido. These are all what? Anionic ligand, having the negative charge. What is about the anionic ligand? The ligand which have negative charge. Can you say? The ligand which have the negative charge. Here, what is the speciality about this negative ligand means? These ligands are ends with the letter O. Okay, the ends with the letter O. What is about the anionic ligand? These are the ligand ends with the letter last letter O. Can you say example? Bromine ion. We are giving bromido. Chlorine ion. We are giving chlorido. Fluorido. Hydroxido. Like that. Ends with O. These are called what? Anionic ligand. What can you say about the cationic ligand? Can you say about the cationic ligand? NH4 plus. We can give you one of the cationic. NO plus. Next, NO2 plus. These are the example. Okay, these are the example. NH4. Ammonium. What's the name of this complex? Ammonium. Hydrosonium. Nitronium. Can you understand what is the meaning here? The letter ends with IUM. Clear? What do you understand about that? The ligand ends with IUM. Ligands ends with IUM. First one is ammonium. Having the plus charge, so we are giving the name is cationic ligand. Ends with IUM. Ammonium. NO plus nitrosonium. Okay, IUM, ends with IUM. Nitronium. These are the cationic ligand. Clear? Having doubt about the anionic ligand and cationic ligand. Next about some of the neutral ligands. Some few neutral ligands have. I told you about previously. I told you that about the NH3. What is about the NH3? Anybody remember NH3? Next one, amine. That is amine. Amine. Here, aqua. Water can be written as aqua. CO, carbonyl. Nitrosyl, NO. These are some examples. Some of few examples I wrote here. Many having, a few have. Then gets written as amine. H2O can be. Say about that aqua, aqua. CO, carbonyl, nitrosyl. Okay, these are the about the naming of ligand. Next about, this is about the first 3 points. If you are learning about the 2 more point means, this is very easy for you. 2 more points. Okay. Next about, we are using a term K. K means kappa. Okay. K means kappa. Okay, we are writing a term, the capital, I think the capital letter. A K term. We are using a K term. We are using here. This K term, where we are using means we are using ambidendane ligand. Ambidendane. What is about the ambidendane ligand? What is the function here means the ambidendane ligand in which more than one coordination is possible. More than one coordination is possible. Okay, first of all, we should be learn about the ambidendane ligand. Okay, what is about the ambidendane ligand means some ligand have 2 or more donor atom. Okay, that you write the definition. Have 2 or more donor atom. Okay, some ligand having 2 or more ligand atom but only one can donate electron pair. But only one can donate electron pair. This is the definition for ambient and ligand. Where at a time, that is also used at a time. Okay. 10. Okay. What's the definition for ambient and ligand? Please note that one. Ambient and ligand. Some ligand have 2 or more donor atom, but only one can donate the electron pair at a time. That we are saying what? Ambient and ligand. What is the example here? We can use the example. What is the example means? The ligand of thiocyanate. The ligand of thiocyanate. What is about the thiocyanate? Thiocyanate means SCN. SCN. This is the thiocyanate. Here, the ligand thiocyanate can bind the central metal atom or ion through either by sulfur or either by nitrogen. Can you understand? Here, this is one of the ambient and ligand. This ligand, sulfur may be attached to the central metal ion. For example, this is the central metal ion. Example, M plus is the central metal ion. M. Here, sulfur may be attached or nitrogen may be attached to the central metal. That is the meaning. Can you understand? Here, thiocyanate can bind the central metal ion through either by sulfur can be attached, or maybe nitrogen may be attached. Anyhow, in a certain condition, if sulfur forms a coordination bond with the metal, then the name we can give thiocyanato Ks. So sulfur binding means we are giving what's the name? What's the name we are giving? Thiocyanato Ks. Thiocyanato Ks. Okay? Sometimes, don't use the dot here. Thiocyanato Ks. Okay. Thiocyanato Ks. Sometimes nitrogen may be bond means we are giving thiocyanato Kn. Okay. For nitrogen we are giving Kn. That means sulfur attached means we are giving what's the name? Thiocyanato Ks. K means kappa. Sometimes nitrogen attached means thiocyanato Kn. Okay, Kn. This is the next rule. I will give the explain. And also, in our textbook having some, I think that the page number 137, page 137, having some examples about the cationic and anionic ligands and everything having. As per the monodendrine ligand having bromido, chlorido, fluorido. For example, bromide. What is the ions about the bromide? Br minus. We are giving the name bromido. Chlorine, that is Cl minus. Chlorido. Fluoride, we are giving F minus. This is fluorido. Okay. And about the sign Cl minus. Cl minus is also what? Ambient ligand. Am I right? Ambient ligand. This also giving cyanido. Sometimes maybe we are giving OH minus hydroxido. Okay, next about the carbonate also having CO3 2 minus. They are giving carbonato. Here, these are the having, and about the carbonate and about the Cn minus we are giving, that is ambient ligand. And about the carbonate is also ambient ligand. These are some example, and also NO2 minus we are giving the ambient ligand. Okay, these are what? They are the ambient ligand. Some of the having. And next one. Next about the one more point. What is about that point means? The previous I told you that Sometimes the coordination entity having more than one ligand at a particular time, the multiple of ligand means 2, 3, 4, etc. can be used, is indicated by adding appropriate Greek prefix. That means, what are the Greek prefix? Di, 2 for di, 3 for tri, 4 for tetra, 5 for penta, and 6 for hexa. Like that we are using the name of the ligand. Okay, that means if the name of the ligand itself contains a Greek prefix for ethylene diamine, this is the point. Ethylene diamine means simply we are using like that En. What is En refers? Ethylene diamine. Okay, what is about the formula? NH2, CH2, CH2, NH2. This is what? Ethylene diamine. As per the IUPAC name, we are using ethane 1,2, ethane 1,2 diamine. This is the IUPAC name, okay? Okay, I will tell you later, okay? Anyhow, ethylene diamine here is an alternate prefix. Another one prefix. Alternative prefix means bis, tris, tetrax, etc. we are using to specify the multiple of such ligand. Okay, we can learn something about that. And about name of the central metal ion. That is a very important. How can you give the name of the central metal? First I tell you about that. How can you say the name of the ions? Next I gave that. How can you tell about that ligand name? Next, the third one is name to the central metal ion. In this mode, I told you that first one is a for ion. Am I right? First one ion. Second one ligand. The third one is for name of central metal. Central metal. Here, in cationic or neutral complex, the element name is used such for naming the central metal ion or atom or ion. And whereas the suffix "ate" is used along with the element of name anionic complex. Simple concept. That means cationic and neutral complex, the element name is used. Okay, the simple one complex, that is cationic, and about the neutral. This is one. Third one. Second one. That is anionic. This is the one. Cationic complex or maybe the neutral complex, the element name is used. For the anionic complex, we are using ate. We can discuss one more time. Please, we can use that one. That means, example, CO. H2O 6 times Cl2. Can you say which complex? Can you say this is the cationic complex, this is the symbol anion. Am I right? Cationic complex. Okay. Next I am writing another one. CO NH3 Cl3. Can you say which complex? This complex having any charge? No charge. But this complex having charge. We are simply separating. That means CO H2O 6 times plus here, this is the what? Complex cation. Plus charge, we are giving the plus charge. Minus charge. So complex cation, simple anion. Am I right? Here, this is a neutral, so we cannot be split the complex here. It's a neutral. Here, first you should be saying, I told you about that first condition. Cation or the neutral, you say the name is, first start with the ligon, second to metal, third is this ion. We are saying the number like that. First goes to ligon, because outside having no ions. So, first priority goes to, that is the ligon. First one is ammonium, sorry, water. Water you should be say as aqua. How much water is there? 6 water molecules. So, hexa-aqua. Cobalt oxide state is 3. Cobalt 3 chloride. Okay? Hexa-aqua, cobalt 3 chloride. Dichloride. Okay, we say like that, no problem. Hexa-aqua, cobalt 3 chloride, like that. Here, first priority goes to here, second, third. Triamine, trichloro, cobalt 3. Okay? Can you see the name? Hexa-aqua, cobalt 3 chloride. Here, triamine, trichloro, cobalt 3. Can you understand? That means, I told you that the cationic complex, the neutral, the element name is used. The element cobalt we are using. We should not write any 8. But the anionic complex, we are using 8. Okay. For example, K4, Fe, Cn, 6. Can you say which complex? 4K plus Fe, Cn, 6, 4 minus. Am I right? Here, how can you say the name? First, potassium. Start number 1, 2, 3. Hexacyano or cyanido. Hexacyanido we can discuss, no problem. Otherwise, hexacyano ferrate 2. Clear? So, that means the anionic complex, you should be writing 8. Okay? This is anionic complex, you are writing the 8. But the cationic complex or the neutral complex, you should be writing the element. Okay? You should be writing the element. I think that our time is over. So anyhow, again we can discuss tomorrow. Those who are interested, you can write at least any two points about the IUPAC nomenclature. Okay, IUPAC nomenclature. Any 2 points. Those who are interested, you can write. Okay, thank you all of you. Thank you. Have a nice day.